second. Can you hear my voice? Okay. Firstly, I should apologize for the last week. Unfortunately, I was busy last week, so I couldn't join to the class. Next week, we will have 2 classes to compensate the last week classes. Okay. During our last topics, we talked about some statistical description of data, and now we will continue the rest of content of this book, this chapter. Okay. One main question is that how can I present data to, for example, to a manager, or what is the best presentation way in a report? What way is more effective for presentation? If someone asks me something like this, I will say that graphical presentation is the best way. Scientists say that if you have one picture, it's better than having 100 text page. One image, one picture is better than 100 page of text. Okay, so when we talk about data, if we decided to present this data to someone else, to manager, to staffs, or someone else, the best way for us is using graphical presentations, using plots, using charts. Here, in this section, in this lecture, we will talk about some of most famous and most common charts, plots, and something like this to present data. We will talk about box plots, histogram, quantile plot, quantile plot, and scatter plot. Scatter plot, and some more plots will be discussed too. Histogram. Histogram means histo means pool, and gram means chart or plot. So histogram means a chart of pool. Maybe histogram is the most common and most popular charts in scientific world. A histogram is is a composite of some bars scattered in a range. For example, um, I have some salary reports and I decided to show distribution of these salaries. Histogram can be used in this case. To do this, firstly, I should calculate the range of salaries and divide them into some uh, parts, some groups, some category. Then, in each category, I can simply count number of salaries on that category and present them as a bar in histogram. If you look at this example here in slide 19, you can see that histogram can tell me useful information about the distribution of such data. Here we can see that in most of cases, for example, salaries, the paid amount is standing between 2,000 to 3,000, or excuse me, between 20,000 to 30,000. And if you look at the range between higher than 70,000, you can see just a few place higher than in higher than 70,000 categories. You can see here in the right corner of this histogram. In most of cases, the height of these bars is 0 or near 0. But in the range 15,000 until 45,000, you can see most of the cases are placed in this range between 15,000 and 45,000. Each category, each bar, each group presents a non-overlapping interval of some variable. Histogram is a good chart for presentation in such cases. One main question about histogram is that how can decided, or how should I how can I define these intervals or these categories or groups? In chapter 3, we will discuss more about histograms because it's very important. How can I how should I define these intervals? Maybe someone defined unique intervals with some specifications. Maybe someone used non-equal intervals. So we should talk about histogram more in the future, but histogram is useful to present and show how data distributed in a specific range. Look at this figure. Both of these histograms shows different distribution. Maybe, for example, try Q. Nuratnan, what do you mean by Q? What is Q? Question about what? Writing question about which topic? You just talk about histogram. There is no question. At this time, there is no question. We will talk about histogram next in the next chapter. For example, look at these histograms. These two histograms. They show different distributions. The bottom histogram has a Gaussian shape, but the upper histogram has not. So histogram is useful to present useful information about distribution of a variable, of of an object. Next plot is quantile. Next useful plot is quantile plot. We talked about quantile in the last class, in the last lecture. As I said, we can find a range between 0 to 100%, and divide a range between 0 to 100 into, for example, 100 equal size groups. Okay. But 3 of these groups are more important than the rest. The first quantile, the second quantile, and the third quantile. The first quantile is placed somewhere that 25% of data is on left side of that, and the rest are placed in the right side of that point. So I can say that the first quantile is point of 25%. The second quantile is 50% and the third quantile is 75%. These 3 points show that amount of data before and after them. So I can imagine a distribution pattern. I can imagine about the distribution pattern of data. If the data is, if for example, the first and the second quantile are near, so the data in this range is more dense than the rest of intervals. So quantile information can be plotted here like this. In increasing order, and it can be mapped on percentile information. I can extend this plot and reaching to another plot, quantile plot, QQ plot. For example, I have two branches. I am a manager of a market with two branches, and I decided to show the relation between the prices in the first branch and the second branch. If total number of, for example, items in these branches are equal, then I can plot quantile for both of them. Oh, excuse me, just wait for. So I decided to compare, for example, prices or something else between two branches. Okay, I plot QQ plot like this. You can see some dot points here. there are Q1, Q2, and Q3, or first quantile, second quantile, and the third quantile. Number of We can see that in both horizontal and vertical vectors, we have 120 items or prices or something like that. Okay, so I plot this, and I reach to a plot like this. What does this plot means? It's a question. What does this plot means? If I look on this plot, I can see that the price in the second branch is higher than the prices in the first branch. You can see a separator line here. Most of points in this plot are placed upper than this line, this separator line. This means that, for example, prices in the second branch is higher than the prices in the first branch. Why this happens, I don't know. Maybe one branch is placed in an area with poor people, and one branch is placed in the area with rich people. I don't know, but this plot shows me the prices in the second branch is higher than the prices in the first branch. Maybe someone say that this is a plot for example, for items sold in both branch. Okay, if this plot shows number of sold items, then I can say that the number of items has been sold in the second branch is more than number of items has been sold in the first branch. So quantile plot can help me in this case, and it can be useful in such cases. One main plot, one more useful useful plot, and one can you hear my voice? Excuse me. Can you hear my voice? Can you hear my voice correctly? My link is weak. Okay, good right now? Can you hear my voice correctly right now? Is it okay? Is my voice okay? Okay. Okay. A scatter plot is another important plot for us. Mostly we use this plot. A scatter plot, for example, look at this plot here in slide 23. You can see a scatter plot. This plot shows that how two different attributes can affect on each other. What is the trend between two different attributes? What is the relationship between two different attributes? When I'm talking about histogram or quantile, just I'm talking about one single attribute. But scatter plots can shows me the relation between different attributes. I prepare some pairs of information from two different attributes. If my plot is a 2D plot, two-dimensional plot, I prepare some pairs of values and I plot them in the area, in a 2D area. Maybe someone tries to use 3D three-dimensional scatter plot. We can do that. Maybe someone try to use a four-dimensional scatter plot. We can do that. We can do it. Okay. So a scatter plot can show me the distribution of and the distribution and relation between two different attributes. Relationship between two different attributes. Okay. One of the useful application of scatter plots is finding correlation between two attributes. Here we have three different shapes of scatter plots. On the top left, plot, we can see a positive correlation between two attributes. Positive correlation means that if I increase amount of one attribute, the amount of the other attribute is increased too. Increasing amount of one attribute means increasing amount of the other attributes. So we say these attributes have positive correlation. If I increase one attribute and at that time the value of the second attribute decreases, we say that we have negative correlation. Negative correlation. If one attribute increases, the other attribute decreases. So they are negatively correlated. And if we couldn't find any relation between two attributes, we can say they are not correlated. In chapter 3, we will show that how we can calculate these correlations. Correlation is standing between -1 to +1. Correlation is a value between -1 to +1. -1 means a negative correlation, +1 means a positive correlation. And if there is no correlation between two items, the correlation value is something near to 0. Some Ahmed Muhammad says that there are two parts, positive and negative. No, there are not two parts. Correlation is a value between -1 to +1. Is if the direction in the scatter plot, the direction is increasing, is upward, we say that those variables have positive correlation. And the direction, if direction is downward, we say that those variables or those attributes have negative correlation. As Ala Abd says right here, that direction specifies positive or negative. This is true. By watching these plots, I can say that two attributes have positive or negative correlation, or maybe they have not correlation. We will talk about these correlations as a mathematical formula in the next chapters. Here, look at these figures. 3 scatter plots are presented here. I couldn't find correlation between them in none of these plots. I couldn't find a specific correlation between attributes. Okay, Hamid Mohammed, do you still have problem? Do you, do you hear my voice correctly? Can you hear my voice correctly? Yes or no? Okay. Next topic is about data visualization. Data visualization gives more insight about information uh, that we have. We map this data into some plots or some graphical shapes so people can understand better, understand more deeply, more deep about these data. Also, sometimes my data set is very large. If my data set is small, I can present it as a table. But if I have a large database or large data set with, for example, 1 million records, one something like that, 1,000 records, I couldn't present something like this in a document, in a report. So if I use data visualization tools, I can show those data effectively. Ahmed Mohammed, I advise you to leave the class and enter to the class again. You enter the class using your cell phone. The problem is with your device. If you can, please don't use cell phones to enter the class. Unfortunately, Adobe Connect has some problems with cell phones because the platform of a cell phone is weak. It's much weaker than a laptop or a PC. So it's not strange to have some problems. Okay. When we visualize data, we can see some patterns, trends, structures, or more relations between data in data of a data set. Okay. Maybe when I visualize data, I could find some interesting regions, some suitable parameters, some interesting patterns, or something like that. Someone Sometimes when I visualize data, I can prove some facts. So visualization is important to create or build a good report, a useful report. Mohammed says that sending a PDF of lecture. Uh, Hamid, I prepare a link, direct link to download the PDF of this book or book or course book. You can find it in the LMS. Okay. There are some visualization method here. For example, pixel-oriented visualization, geometric projection visualization, icon-based hierarchy, or visualizing complex data. I will try to talk about them in brief. Pixel-oriented means that uh, I put a color for each pixel in a plot, a color for each pixel. Each pixel is related or is referred to a single object in my dataset. Sometimes I can use pixel oriented for different dimensions. For example, if my dataset has m dimensions, I can create m different pixel oriented plots. For each dimension, each record has a specific value. I, sh I should translate this value into a color. A value in a record is a pixel for me. So what is the color of this pixel? The value tell me what's that. Also, I can handle the colors. For example, you can see the red color for hot as a hot color and blue color as a cold color for cold. For example, if you have a temperature attribute, you can simply use this. Red to blue color. A complete range between them. Uh, if you, Muhammad, if you still has problem with the LMS, please contact to Dr. Rahmani. Because in the near future, I will ask you to do some assignments. I will prepare them in the LMS. So if you have not access to the LMS, you couldn't submit your reports for assignments. If someone has this problem, please contact with Dr. Rahmani. Okay. There are some pixel-oriented visualization here, for example, there are 4 plots here for income, credit limit, transaction volume, and age. You can see each pixel here and different colors related to the value of each pixel. Maybe uh, you have a data set with too many dimensions. So you can use, for example, circle segment plots instead of simple pixel-oriented plots like this. You can use circle segment plots. What does it mean? These plots consist of different dimension. Each dimension is related to a specific dimension in dataset. So if you are trying to show all dimensions of a dataset in a single plot, you can use circle segment plots. It can show you, it can give you a presentation of a multiple dimension dataset. There are 2 examples here in this slide. Sometimes you are trying to use geometric projections techniques for visualization. There are different methods to do this. For example, driving scatter plots, using direct visualization, landscape, and someone like this. For example, this is a direct data visualization example. This is a scatter plot matrix, which it shows you the relation between different attributes in iris dataset. We will draw this plot later in the class when I talk about and using Veka software. I will show you this plot. How can I draw this plot? I will show you. This is the landscape plot. This is a parallel coordination. I don't know. There are different methods here. One more technique is using icons for visualization. For example, when you are trying to use social networks, you can see some icons. For example, this icon means I'm sad. This one means I'm happy. And so on like this. I'm using these icons to tell someone else about my emotions. So I can use a similar method to present my data. For example, churn of faces or stick figures, or using shape coding, color icon, tile bars, or something like that.